What is up people, this is YSHQ and this video is just an extension to the last part that was on the 2.8 inch SPI TFT LCD display with an ILI9341 controller. But the only difference in this video is going to be me using an ESP32 and Arduino IDE instead of a Raspberry Pi and Python. So if you haven't seen that video, go check it out. The links will be in the description and there'll be a card as well. So let's get started. So first of all, you'll need an ESP32, which I made a video on a while back. It's linked down there as well, and the LCD display. So for those who haven't seen it, like this is the LCD display. It's 2.8 inches diagonally, 240 by 360 pixels. It has a touch interface inbuilt, and it also has an SD card slot at the back, which can be used. So that's about the LCD. Now what we will need is two things. First of all, the library. So the first library that we'll need, which is required, is the ILI9341 library from Adafruit. So we'll just search for it in the library manager and just install it. Since I already have it installed, it says it's installed. And the next one we'll need is the GFX library or the graphics library. It's usually installed, but if you don't have it installed, just install it. And for the demo project, I just used the demo from Marty MacGyver's Github repo. As for wiring the ESP up, just follow this diagram. VCC goes to 3.3 volts, ground goes to the ground pin, CS goes to GPIO 5, reset goes to GPIO 17, DC goes to GPIO 16, SDI goes to GPIO 23, SCK goes to GPIO 18, LED goes to VIN, which is going to be 5 volts, and SDO goes to GPIO 19. Just make sure that you see which GPIO pins are where on your board, because it's going to change based on the board that you're using. Now let's get back to the demo. So over here, since the display is SPI based, we included the SPIO.h library, the Adafruit graphics library, and the Adafruit ILI9341 library. Then you define all the pins that you used. These are the pins that you already saw. Then what we do is we just set these pin values in the library and then we set it up. So tft.begin, this will just call in a routine which just sets up the display, and then these things are for diagnostics, but they are normally not needed. Then let's get to the loop. Now this demo is pretty simple to understand, but I'll still show one part of it. So it begins by just printing benchmark time and then a delay, and then we fill the screen. Now this next line, this just calls it a routine test fill screen, and if we scroll down, it's already assigned over here. And what this will do is it will fill the screen with black, red, green, blue and black colors, and yield, brackets and a semicolon. It will just output the TFT buffer on the LCD itself. Next, the text part. So in the text, we are just sending in text, and since we need it in 4 rotations, because you could use the screen horizontally, vertically and in the opposite directions as well. So we just rotate it by 90 degrees. So text rotation, print the rotation, which is going to be 0, 1, 2 and 3, and set rotation as 0, 1, 2 or 3, and then we just go to the test text class. Hence we come over here. Now we set the cursor to 0, 0, which is going to be the top left side of the screen, and it will set the text color to white and the text size to 1, and it will print hello world. Then a different font color and a different font size, and print another numbers, and the same thing goes on for a few things. Once this is done, what happens is it goes back and then it will yield it out, and then it will change the rotation again and come back and print it out again. The next one is for the line. And the same thing happens. It'll call the test lines function. It just has it has 4 variables which are user defined. And since a line is just defined by 2 static points, we just set those points as x1 y1 and x2 y2, which is the x coordinate and the y coordinate of the first point, and the same for the second point. And w is going to be the width, and h is going to be the height of the TSP display. And then we just fill the screen with black. That means it's just going to erase everything that was previously on there. Then we just set the first points to 0 0, y to h1, and then start with x2. It's defined in a for loop as x equals 0 is going to be the starting point, x is under w, which is the width, and x equal to x plus 6, which is just going to increment the value of x by 6. Then it goes to the y and it changes it and yields it out, and the same thing goes on and on for a few times, where the variables of x and y, x1 y1 x2 y2 change, and it just displays it out. There are these other functions which I'm not going to explain, but it's the same, like test fast lines. This is going to print them lines one by one, but this is going to be faster. Test rectangles, fill rectangles. So this is just going to show the outline, and this is going to fill the rectangle with a color, which is going to be magenta. Same goes with circles. This is a filled one. This is an outline for the triangle, non-filled and filled. Rounded rectangles, non-filled and filled. And that's it. It's going to keep on looping this thing unless you decide to make something with it. Over here is the demo, which is going to be displayed now. So thank you for watching this video. Like this video if you liked it, dislike it if you didn't, subscribe to the channel, share it, click on that notification icon, and see you next time.